look at this example. I have a function w that has variables x and y, and both an x and y are functions of s and t, and we'd like to find the partial derivatives, these guys. So let's use a diagram to help us to write down the formula for a chain rule. So w is a function of x and y. Both x and y are functions of s and t. Okay? And here the stick connecting w to x represents dw dx with the weird partial, or the weird d, and this is this is dx ds. I'm using this weird notation because x is also a function of multivariables. And down here we have dx dt. Here we have dw dy ds dy dt. Okay? So when you solve a problem, you don't have to write everything down. Like, you don't have to write the dw dx. As long as you know what you are doing, you don't have to write down. So I'm writing just to show you what I'm doing. Okay? So I want to find dw ds. What does that mean? That means I'm going to find all the branches that connect w to s. So that will be this branch, and I have another branch that's here. Okay? So now I read the diagram, tells me dw ds is equal to dw dx times dx ds plus dw dy and dy ds. Okay? So with the functions, the given functions up here, I can easily find the partial derivatives and plug those into the formula, then I'll be okay. Similarly, dw dt you find all the branches that connect w to t. So I found this two. And so reading the branch, I see that this is equal to dw dx dx dt plus dw dy and dy dt. Okay, so now we need to find what these partial derivatives are. When we have those, we're ready to write down the answer. Okay, so first I need dw dx and dw dy. So dw dx, differentiating this function with respect to x, I get 2y. dw dy, treating x as a variable, differentiated with respect to y, I get 2x. Okay? dx ds, treating t as a constant, differentiate this, I get 2s. Similarly, dx dt is equal to 2t. Okay, treating s as a constant, focus on the t squared. dy ds, so treating t as a constant, so this is variable times 1 over t. Okay, that's that. And now dy dt. Okay, so s is a constant, so leave the s there. And focus on differentiating 1 over t. So this is t to the minus 1. So that's minus s t to the minus 2. So this is a negative s over t squared. Okay? So the first two functions, you might think there's a symmetry, but it's not. It's really just doing the regular partial derivatives. Okay? So do not create your own rules. Just follow the derivative rules. Okay? You don't have extra rules. All right. Now we have all the ingredients listed here. You just need to put them in place. dw dx, that is 2y. Okay. dx ds, that is 2s. Plus dw dy, that is 2x. Times dy ds, that is this guy. So that's 1 over t. All right. And I need to convert the variables in the middle to variables on the bottom. So let me continue. Y is equal to s over t. Okay. X is equal to s squared plus t squared. Okay, so 2 times x times 1 over t. All right, let me simplify this a little. 4s squared over t plus 2s squared plus t squared over t. Okay. If you want to, you can separate this and put the x squared over t together with this one. So that would be 6s squared over t plus 2t, because t squared over t is equal to t. Okay. All right. Next one. I have 2y and I have dx dt. So dx dt is 2t plus 2x times dy dt. So this is dy dt minus s over t squared. Okay, and we plug in as usual. So this is 2s over t times 2t plus 2s squared plus t squared times minus t s over t squared. Okay, so t cross out at 4s. Okay, and then I do s squared times this, so that's minus 2s cubed minus t squared. And I do t squared times that, t squared and t squared they cancel, so minus 2s. So in the end, I have 2s minus 2s cubed over t squared. Okay, so this is what do we have for dw dt.